Hi students, so we were studying the chapter 5, that is continuity and the differentiability, and in this chapter we have already came across what is continuity, and regarding this one then we have came across the introduction part of the differentiability when we say that the function is differentiable, these concept, and regarding the composite function and how we are differentiating the composite function, as well as the rule to differentiate the composite function, that is a chain rule. So all these things we have came across in our previous video. So today in this video let us come across the derivatives of implicit function. So my first question, what are these implicit functions? So let us understand that first, then let us go to how we are finding the derivatives of those function. So now you can see here the two equation. So in the first equation you can see here x minus y minus pi is equal to 0, and in the second equation x plus sine xy minus y is equal to 0. So here I can write or rearrange this equation 1 as how I can rearrange this one. I can rearrange as y is equal to x minus pi, right? So I can rearrange our first equation in this manner. So clearly you can see here that our x, it is a independent variable, and our y, it is an dependent variable. As the value of x varies, value of y also varies. So clearly y is depending upon the values of x. So this equation can be isolated. So isolated means what? I can separate the independent variable and dependent variable, where dependent variable is on the one side and independent variables are on the other side. So whatever there is a changes in the independent variable, so there will be changes in the dependent variable, since y is depending on y, right? Since y is depending upon x, right? So such type of equations or such type of functions are called as what? Explicit function. So in the explicit function, I can isolate the dependent variable. So here y is the dependent variable, so I kept that variable on the one side and the independent variable on the other side. So such type of functions are called as explicit function. Now let us come to the second equation, that is x plus sine xy minus y is equal to 0. So by looking into this equation, my question for you people is that can you isolate this equation, that is keeping the dependent variable y on the one side and independent variable x on the other side? Suppose if you try, means you can write y is equal to x plus sine y, but also here is y, right? But you can separate here y from this sine xy, because here y is the angle of the sine function. So you can't separate this y from this equation, or you cannot isolate the dependent variable on the one side. So such type of equations are called as implicit function. So in the implicit function, we cannot isolate dependent variable on one side of the equation. But in the explicit function, we can isolate the dependent variable on one side of the equation. So this is the difference between the implicit function and the explicit function. Now my question is what? How we are finding the derivatives, or how we are going to differentiate the implicit function. Now you can see here our function is what? X plus sine xy minus y is equal to 0. This is our implicit function, and the explicit function was what? X minus y minus pi is equal to 0. Upon rearranging, what I got? Y is equal to x minus pi. Suppose if I need to differentiate this one, if the question was asked differentiate this one with respect to x, means how we used to differentiate? Dy by dx is equal to d by dx of x minus d by dx of pi, right? So what is the differentiation of x with respect to x? It is 1. Clearly we know that pi, it is a constant. So differentiation of a constant with respect to x, it is 0. So value is 1 here. So this is how we are going to differentiate. Similarly, we are differentiating here, but we cannot separate that or isolate the independent variable on the one side, but we are differentiating here by keeping in the mind that we are differentiating the thing with respect to x here. So this thing you should keep in the mind first. So first thing, d by dx of x. I am going here step by step. If the concept get into your mind clearly means, then you can do it in a single shot. So the next is d by dx of sin xy minus d by dx of y, which is equal to 0. So what happens? D by dx of x, it is 1 plus d by dx of sin xy. Clearly it is a composite function. So what happens? First, using the chain rule, cos xy into d by dx of xy minus this one is dy by dx itself, which is equal to 0. So now let us continue. 1 plus cos xy. So here it by using the product rule. So we know that how the product rule goes. First function, differentiation of the second, that is dy by dx, plus second function, differentiation of the first one, dx by dx minus dy by dx is equal to 0. So what happens? 1 plus cos xy. Here again x dy by dx as it is, plus y. What is the differentiation of x with respect to x? It is 1. So y into 1, it is y itself, minus dy by dx is equal to 0. So you can keep this function as it is, saying that this is the derivative of the given function, or you can keep or rearrange in this manner, that is 1 plus x cos xy dy by dx plus this cos xy is multiplied to both the terms, plus y into cos of xy minus dy by dx is equal to 0. So from this two terms, keeping these two terms here, move or rest of the thing to the other side. So what happens? X cos xy dy by dx minus dy by dx is equal to minus 1 minus cos xy, or by taking the minus common I can write it as 1 plus y cos y. So here if I take dy by dx as common means, what we are going to get? X cos xy minus 1 is equal to 1 plus y cos xy. Clear? So therefore dy by dx is equal to minus 1 plus y cos xy divided by, here also if I take minus common outside means it becomes 1 minus x cos xy. So this minus get cancelled. So this is the derivative of the given function. So this is how we are going to find the derivatives of the implicit function. So you might feel, by looking into this long procedure, you might feel difficult in one stretch, but upon practice clearly you will get to understand how we are going to differentiate. So that's why I said in the beginning, chain rule, it matters a lot, because here we use the chain rule, which is one of the small part in this type of question. So in our previous, chain rule was the big thing, but when we are solving the implicit function, chain rule is one of the minor step. So that's why chain rule is the foundation. If you don't know here itself, then solving this many parts is not at all possible for you people. So chain rule is the basic thing which you must be known. So this is how we are finding the derivatives of the implicit function. You will get to clear picture of finding the derivative of implicit function by solving few of the example as well as the exercise problem. So now let us solve few of the examples to get or to better understand how we are finding the derivatives of implicit function. So here are few of the examples. So we need to find what? Dy by dx. So if they have given one of the function, that is x minus y is equal to pi. So clearly the thing is we need to differentiate with respect to x, right? So suppose some people's, or we can think about by looking into a question, that is I can write this one as y is equal to x minus pi, then dy by dx is equal to 1, since dx by x is 1 and differentiation of pi with respect to x is 0, since it is 1. So this is also correct. So another method, or the alternate way, I mean the practice which we are going to do, that is x minus y is equal to pi, right? So there we need to differentiate with respect to x. So how it will goes? D by dx of x minus y is equal to dy dx of pi. So that is we are differentiating the equation with respect to x on both the side. So what happens by the algebra of derivatives, this is applied to both the things. So what happens? D by dx of x minus d by dx of y is equal to dy dx of pi. So now what does this implies? Differentiation of x with respect to x, it is 1. This one is dy by dx itself, and this one is equal to constant. What does that implies? Dy by dx is equal to 1. You can see here answer is same in both the cases. Answer is same in both the cases. So purely it goes with which method you are going to use. So whether if by looking into the function you can say that it is an explicit function, means you can isolate the independent variable one side, dependent variable one side, and then you are differentiating. If you are fine with it, okay. Or by looking into the equation, we are not bothered whether it is an implicit or explicit, we are differentiating with respect to x, means then you can go with this method. So whatever the method, it's depend upon you people how you are solving. So there is a next thing, that is they are given y plus sin y is equal to cos y. So how the thing is, first we need to find dy by dx. So we are differentiating with respect to x. So differentiating with respect to x means what happens? D by dx of y plus sin y is equal to d by dx of cos x. Now what happens? D by dx of y plus d by dx of sin y, and here it is dy dx of cos x itself. Now let us go with it. So this is dy by dx itself. Differentiation of sin. What is the differentiation of sin? It is cos y, but we are differentiating with respect to x. So cos y dy by dx. Here it also differentiation of cos x. What does the differentiation of cos x? Differentiation of cos x is minus sin x, as I said yesterday or in the previous video, that is d by dx of cos x is equal to minus sin x. After differentiating, we are again differentiating that variable with respect to x. Since dx by dx it is equal to 1, we are not mentioning this one or not bothered about this one. That is what here it is also followed. Differentiation of sin is cos y and differentiating that variable with respect to x. Here also differentiating this variable with respect to x. Since differentiation of this variable, that is x variable with respect to x, it is 1. So we are not bothered about that variable that much because it is 1. So now from here, if I take dy by dx common, what is the remaining? 1 plus cos y, which is equal to minus sin x. So clearly dy by dx, it is equal to minus sin x divided by 1 plus cos y. So this is the derivative of the given function dy by dx, that is minus sin x divided by 1 plus cos y. So upon saying dy by dx is equal to this one, we need to say at which point this one is defined. So clearly when it comes in the fraction form, means we are obviously concentrated much more upon the denominator. So the denominator should not be equal to 0. Suppose if denominator becomes 0 means then the function becomes not defined. So 1 plus cos y, it should not be equal to 0. So 1 plus cos y should not be equal to 0 means clearly cos y should not be equal to minus 1. If it becomes minus 1 means 1 minus 1, it becomes 0. So for which angle we are going to get our y has, cos y has equal to minus 1, that is y should not be equal to 2n plus 1 pi. So if y is not equal to 2n plus 1 pi means then we can say that this one denominator is not at all going to vanish. Suppose y is not equal to this angle means then this is defined. So the derivative of a given function, that is y plus sin y is equal to cos x, the derivative of this function is this one. This is how we are finding the derivatives of the implicit function. So after the implicit function, finding the derivative of implicit function, the next concept followed by the derivative of implicit function is finding the derivatives of inverse trigonometric functions. So we already came across the 6 inverse trigonometric functions which we have already learnt in our chapter 2 regarding the inverse trigonometric function. Now we need to find what are the derivatives of those inverse trigonometric functions. So first thing is we need to find the derivative of f of x is equal to sine inverse of x. So we need to find the derivative of this function by assuming it exists. So we are assuming that the inverse exists. By assuming that one, we need to find the derivatives of this inverse trigonometric function, that is sine inverse of x. So let us start by finding. So I'll take that one as y is equal to sine inverse of x. So what happens, y is equal to sine inverse of x means then x is equal to sine y. So x is equal to sine y. Now I am differentiating this one, x is equal to sine y with respect to x. What happens, d by dx of x is equal to d by dx of sine y. So differentiation of x with respect to x, it is 1. Differentiation of sine is cos y, and we are differentiating, since we are differentiating with respect to x, we are having dy by dx. Since they asked the derivative of this inverse trigonometric function, what we are going to get, dy by dx is equal to 1 by cos y. So we can keep this 1 by cos y in one of the beautiful manner. So I'll call, let it be the star. So what is that beautiful manner? We are representing the derivative of sine inverse of x. That is nothing but, we already know the identity, one of the beautiful and very easiest identity, that is cos square y plus sine square y is equal to 1. That is cos square theta plus sine square theta is equal to 1. In place of theta I have written y here. Now substitute this identity to cos y. So cos square y means what happens, 1 minus sine square y. So cos y means what happens, square root of 1 minus sine square y. So now in the star, in place of cos y, I am substituting it by square root of 1 minus sine square y. So that implies dy by dx is equal to 1 divided by square root of 1 minus sine square y. So clearly 1 minus sine square y. So you can see here sine y, our sine y is equal to x means sine square y. What happens, that one, it becomes square root of 1 minus x square. So the derivative of sine inverse, it is nothing but 1 divided by square root of 1 minus x square. So this is how we are finding the derivatives of 1 by 1 the inverse trigonometric function. By looking here, 1 by cos y itself is also okay, right? By thinking that this is also derivative, but here we have changed this x is equal to sine y. y is equal to sine inverse of x, that has been changed into x is equal to sine y. So we need to bring back into the original form, right? So that is we are resubstituting. So that's why the derivative of sine inverse of x, it is nothing but 1 divided by square root of 1 minus x square. So in your chart, which I have already mentioned, keep one chart of the derivatives. In that, derivatives of inverse trigonometric, add that one heading. In that, first identity comes, that is derivative of sine inverse is 1 divided by square root of x square. Similarly, you can find the derivative of f of x is equal to cos inverse of x. This is for do it by yourself part. So clearly the derivative of cos inverse of x, that is dy by dx of derivative of cos inverse of x, it is nothing but minus 1 or minus of 1 divided by 1 minus x square. So this is the derivative of cos inverse of x. So finding this one is your work, or it is your homework for your people for finding the derivative of cos inverse of x. Similarly, finding the derivative of f of x is equal to tan inverse of x, assuming that inverse exists. So I can take y is equal to tan inverse of x. I can write it as x is equal to tan y. So now I am differentiating x is equal to tan y with respect to x. What happens by differentiating that one with respect to x? D by dx of x is equal to d by dx of tan y. So differentiation of x with respect to x, it is 1. Differentiation of tan, it is nothing but secant square y, and we are differentiating that variable with respect to x. So dy by dx, what is the value of dy by dx? It is 1 divided by secant square y, and we already know that 1 plus tan square y is equal to secant square y. So I am replacing that secant square y by 1 plus tan square y. So clearly you can see here I have taken tan y as x, it becomes 1 divided by 1 plus x square. So clearly the derivative d by dx of tan inverse of x, y is tan inverse of x, right? Derivative of tan inverse of x is 1 plus x square. So this is how we are finding the derivative of tan inverse of x. Do it by yourself part, finding the or proving the derivative of cot inverse of x, it is equal to minus 1 divided by 1 plus x square. So this is, you need to prove it by yourself. This is also the same procedure what you can see here. That's why I am giving this one for doing it by yourself. So derivative of cot inverse of x is minus 1 divided by 1 plus x square. The next is finding the derivative of secant inverse of x. So I can write that one as y is equal to secant inverse of x. That implies x is equal to secant y. Now I am differentiating this one with respect to x. So what happens? D by dx of x is equal to d by dx of secant y. So now differentiation of x with respect to x, it is 1. D by differentiation of secant is what? Secant y into tan y, and we are differentiating that variable with respect to x. So clearly now dy by dx is equal to 1 divided by secant y into tan y. So let it be, I'll call this one as star, let it be a side. So we know that again the identity, the famous identity, that is 1 plus tan square y is equal to secant square y. So here for secant y I am having x, but we don't know what is the value for tan y. So I am substituting it for tan y. What happens? Secant square y minus 1, square root of secant square y minus 1. So clearly I am substituting now the value of tan y and secant y in this equation. What happens? 1 divided by secant y, tan y is replaced by square root of secant square y minus 1. So clearly secant y is equal to x. So what happens? 1 divided by x into square root of x square minus 1. So this is the derivative of secant inverse of x. So this is the derivative of secant inverse of x, that is derivative of secant inverse of x is 1 divided by x into square root of x square minus 1. Similarly, you can find the derivative of cosecant inverse of x, that is equal to minus 1 divided by x into square root of x square minus 1. So this is by do it by yourself part. So you need to verify or find the derivative of cosecant inverse. Now you have the derivatives of all the trigonometric function. So first thing, derivative of sine inverse of x. What is the derivative of sine inverse of x? It is 1 divided by square root of 1 minus x square, and derivative of cos inverse of x, it is nothing but minus 1 divided by square root of 1 minus x square, and derivative of tan inverse of x, it is equal to 1 divided by 1 plus x square, and derivative of cot inverse of x, it is equal to minus 1 divided by 1 plus x square, and derivative of secant inverse of x, it is equal to 1 divided by x into square root of x square minus 1, and the last but not the least, derivative of cosecant inverse of x, it is equal to minus 1 divided by x into square root of x square minus 1. So these are the derivatives of 6 trigonometric function. Since all these are functions, now let us know what are the domain. The main thing, what is the domain of these inverse trigonometric the derivatives. Derivatives are this one, right? What is the domain of these functions? We need to find it out. So clearly when I talk about the domain, it is clear that the value of input value. So input value is clearly here x. So domain of the function means since it becomes here fraction, one thing is clear, denominator should not be equal to 0. Since the denominator should not be equal to 0, clearly what happens, our 1 minus x square, it should be greater than 0. So clearly domain means what? 1 minus x square, it should be greater than 0. It not be even greater than or equal to 0. It should be greater than 0. What does that implies? X square is less than 1. Because the negative inequality, the sign changes, which you have already learnt in your class 11. So what does that implies? X is less than plus or minus 1. So x is less than plus or minus 1 means clearly what is that 1? It is from minus 1 to 1, where minus 1 and 1 are not at all included. So it is lying between minus 1 and 1. So the domain of derivative of a sine inverse function, it is nothing but minus 1 to 1. Similarly, the domain, since here it is also the denominator, it is the same thing. The domain of cos inverse is also from minus 1 to 1. When it comes to the finding the domain of tan inverse function, you can see input value here, denominator should not be equal to 0. It becomes 0 when x square is equal to minus 1. So since it is a square, square cannot be negative. So there is not at all possible values of x, so that x square becomes minus 1. So clearly the domain of derivative of tan inverse of function, it is a set of real numbers. Similarly, the domain of the cot inverse function, it is also the set of real numbers. So the next is finding the domain of secant inverse, derivative of secant inverse. So clearly here also comes 1 by x and x square minus 1. So the first thing, So here 1 by x, here 1 by x means here x is not equal to 0, that only follows here. But when it comes to here, since this value x square minus 1, it is lying between the root, value should be positive first thing, and x square minus 1, x square minus 1, it should be greater than 0, and clearly our x square, it cannot be equal to positive plus 1. So x square cannot be equal to plus 1 means clearly x square, it should be strictly greater than 1. X is strictly greater than 1 means what does that implies? X should be strictly greater than plus or minus 1. So strictly greater than plus or minus 1 means where does the values are lying from? It is lying from minus infinity to minus 1, where minus 1 is not at all included, union from 1 to positive plus infinity, where this one is also not included. So the values lying from minus infinity to minus 1, union 1 to infinity. So this is the domain of this derivative of secant inverse function. Similarly, the domain of the cosecant inverse function is also minus infinity to minus 1, union 1 to infinity, union 1 to infinity, the union of these two sets. So these are the domains of which domain, the domain of which function. So these are the domains of the derivatives of the inverse trigonometric functions. What the derivatives we got, the derivative, this one's domain we are talking about. We are not talking about the domains of the inverse trigonometric function. We are talking about the domains of the derivatives of inverse trigonometric functions. So this is regarding the domains. So this is what the 6 derivatives of 6 inverse trigonometric function. So we will come to clear understanding how these derivatives of inverse trigonometric functions are used to find the some of the problems when we are solving the exercise 5.3. So in the 5.3 exercise, we are solving the exercise based upon the implicit function and the derivatives of inverse trigonometric functions. Upon these two things we are solving the exercise 5.3. So before going to the exercise 5.3, make clear what and all the things you must be thorough with. First thing, chain rule. Before chain rule, derivatives of all the functions which you have learned till now, derivatives of all the functions, then chain rule, then how we are dealing with the implicit function, derivating of the implicit function, as well as the derivatives of the inverse trigonometric functions. So if you know all these things means then solving the exercise 5.3, it is a very easiest one. Suppose if you have any doubts in any part of the details which I have given in this video, if you have any doubts means you can ask me at the any time, so I can clear your doubts. So that's all regarding this video, students. Thank you.